Hello and welcome everybody to a new video. So this is the third video in my series about learning some Rust. So we're coming in this week with a new project. You read the title, so you know what we're doing. We're making a Discord bot in Rust. So making a Discord bot is something that I'd wanted to do for a little while. And what I actually did for this one was I took an old bot that I had made for Slack, and I basically ported it over to make it into a Discord bot. So it does pretty much the exact same thing. You interact with it the same way. Um, kind of a silly thing. I really enjoyed making it way back when I originally made it for Slack, and so porting it over to this was fun and pretty amusing as well. And it is now also fully live on Discord. So there's a link in the description where you can install it onto your own Discord server if you want. It doesn't do anything crazy, but it is kind of funny. So that said, let's have a look at what it does, and then we can dig into a little bit about how a Discord bot works, and what about this made me think it was a good thing to do to learn some Rust, and what sort of stuff the considerations I had around that. So, first of all, let's have a look at the Discord bot. So, this is Discord, and I've kind of spoiled it already. You can see what it does. Basically, it's called WAT. You type slash WAT into Discord, hit enter, and bot responds to that. And that's literally it. So yeah, you can say what in a conversation with a big duck. And yeah, this is this exact same app I have built in Slack. And weirdly enough, as I built it as purely a thing about let's figure out how to build a Slack bot. And it's totally pointless and silly, but people like it, and it's to this day I think like the most used thing that I've ever just thrown at the internet. So that's kind of cool. So yeah, maybe it'll pick up with Discord, and maybe Discord will be the most used thing I've ever made it for. Anyway, doesn't matter. Discord bot, how does it work? And what about it is going to make it a good Rust beginner project? So basically, to make a Discord bot, similar to making a Slack bot, and kind of any other bot really, the way they work is basically they're just like a web server, or a website type thing that you just interact with, and it pulls data. So pretty much you create a web server that's going to sit there, and it's going to receive requests from you know Discord or from Slack. When you do commands or do actions, it's going to receive some input, and then it responds with something. Um, and that's really it. So that's about like the most basic version you can have. In this case, the version you've seen is what you might call like a slash command bot. So in Slack, that was like that's its whole kind of main category of types of bots, or like slash command bots. In Discord, the bot ecosystem is a little bit different, but slash commands still exist and essentially use it the same way. So the way this works is you're on Discord, you type slash wat. That sends a request to my server that's running this Discord bot that we're going to talk about the code for. My server responds with some response. In this case, it's a collection of data that contains in it that image and the text that says what, and then it injects that into the conversation, and that's it. So it's basically a call and response type thing. There's some other stuff in there that's kind of important, which I'll get into a little bit later, because some of it's actually a little bit tricky if you've not done it before, and I found it a little tricky to work with in Rust. I had to kind of do some research on it. Um, and there's also some authentication stuff. So there's a whole flow that you use to um, install the app, which I can just show you a little bit about how that works, and I can show you where it's handled in the code. It's not super complicated. It's something called OAuth if you've not used it before. Um, but yeah, you can dig into it. So let's have a look then at how we set this up. So I'll show you actually. First thing I want to show is maybe the uh, developer portal in Discord. So if you want to make your own application, you basically need to log in and set up an account with Discord, and then you need to register in the developer portal. So from here, you can do all sorts of different things, but the applications is the one we're interested in. So you can see my applications are here, and I've got the WAT app. So I can go up here, create a new application if I want. So once you've created an application, you can fill in all these details, give it an icon, and stuff like that, and it starts to give you some scary looking things like these things, which you might not understand. You can read the docs, figure it out more. I can point to some of them later on. And it's going to ask you to start providing like URLs to things that are to do with your app. Um, Again, there's a very good start guide, basically. This thing you can follow building your first Discord app. They go through it with some good examples. Some of it I found a little bit. I had to do some extra research around it because I didn't quite get what it meant in some of the cases. Um, but yeah, it is pretty good. The documentation here, if you go through all of this documentation, it's incredibly detailed. It might be a little difficult to understand at times, but if you figure out what you're looking for and you find the points in it, it's all really clearly spelled out. It's just some of it you have to. I had to make a few leaps to realize what exactly I was looking for, but the information's all there. It's quite well documented, so it's worth a look. Anyway, going back to our app, yeah, we have some basic config stuff. We can go to the OAuth section, which is what I was talking about earlier on. So this basically sets up how you would install the app and stuff like that. You have to select permissions for the app that you wanted to have. And then there's also this bot section where you also have to give it other permissions. I don't want to get too deep into the details of this because it is all covered in the setup guide. I just wanted to point out a couple of things in here where you can see it. But yeah, I'll come back to them as well. So let's see. The first thing we want to have a look at is say the homepage and the installation. So if I go to the website that I posted this on, uh, we get this website. So this is just a static web page that is being run actually by the Rust code that we're going to look at. So it's on this domain. AzureWebsites.net is so I host all of my stuff on Azure. And in Microsoft Azure, you can create an app and get like a fake this kind of dummy domain thing for it. It just subdomains your app name to it and gives it this. But this gives you free like SSL encryption stuff like that out of the box. So that's pretty handy. And I don't really care about the domain name specifically for this toy app. It works fine, so I don't really worry too much about it. But from here, you'll see that we've got a little description about it, and we have an install button. So this install button basically will drop us onto a link in Discord. So you can see down the very bottom of the screen here, it's not super visible, but basically it's this big long URL, which basically will redirect your browser to it, and it's a page in Discord's own app, and then from here you can authorize the app to be installed on your Discord server. So if I can click on this, and you see it opens up here. So it's asked me what I want to do. I could select a server that I want to install it to. I'm not going to install it to a server because it's already installed on the server that I manage, which in this case is just my little sandbox one. But if you follow this through, it'll do this dance where it's asking you what you want to be able to do and what you want to approve that it's able to do that. And you click the button and it'll drop you back onto the website and say, congratulations, you installed it. At that point, you should get a little ping, which you'll probably see as, say, something like this here. What just showed up? And then you'll know that the app is ready to use. So at this point, then it's exactly as I said earlier. You can type in the wat command, and you'll get your response. And that's basically the whole flow of how the app works. So with that kind of very quickly glossed over, let's have a look at some code. Let's see how I implemented this in Rust and all the things. Basically, it's just a web server, but it's a web server that does a few different things. So let's dig into how it does those things, what kind of Rust library packages I use to be able to do all this. So let's start off here. So this is a basic Rust web app that I built in a library called Actix. Actix, I'm not sure. Actix, Actix. So Actix Web seems to be a pretty well known framework for doing web stuff in Rust. There's a few other frameworks that are available, but this is kind of the one that I settled on for ease of understanding for me. It's kind of a what's the word for it? a mental model that worked for me comparing with things I've done before. And yeah, just general kind of seemed to be quite user friendly. There are super low level, really basic versions of this kind of thing. And then there's also much more high level versions that seem to do a lot of features. There's one particular one called Rocket that seems to be very popular. Um, but this kind of ticked a lot of the boxes for me. It was simple, not a huge amount of code. And once I sort of got to understanding it, it kind of made sense to me. So this is what we used. Um, the basic part of this, and actually one thing I should also say is that, with something like say like Ruby on Rails, if you're familiar with it, you've got Rails new application spins up, and that's it, and everything's there. It has loads of convenience methods. It has loads of like convention over configuration stuff that just makes it work. This stuff, if you're getting into it, is not going to be the same. I found like a lot of packages that depend on each other, and like things you had to install and little bits you had to do to make all this stuff work. It's all mostly relatively well documented, but you just have to kind of know where you're looking for. So I'll point to those things as I point them out. The first place you'll see that is this thing here, which is around the main method for the app in our main file. So this is obviously, being a Rust app, main method is basically the main entry point for our whole app here. And this spins up a bunch of like basic boilerplate stuff, including spinning up the actual HTTP server itself. And the first thing you notice is this annotation thing up here, which says that it's a Tokio main method. So what is this? And what does this do? So this is, as you see here, a runtime for writing reliable network applications without compromising speed. So an event-driven, non-blocking I/O platform for doing asynchronous applications. So to make this thing work the way you'd want it to, which is that, say, a HTTP server needs to be able to handle multiple requests at the same time, um, this is basically how you can do that with an asynchronous programming environment. So async, which is what you see this method is annotated with, async is an important thing in Rust. I'm not going to go too deeply into it here, but basically it uses this await thing, async await, which is just an asynchronous programming model for concurrency. But it doesn't. Rust itself doesn't actually support the async stuff itself. It allows you to hook into it to be async, but it doesn't actually support a runtime for things to be async. So that's why you need something like this, which provides that runtime under the hood. And so that's a dependency here to be able to use this Actix web server thing. So yeah, stuff like that is stuff that I had no concept of exactly how that would work, and it was something that took me. I didn't really understand exactly how it works, and I'm sure I still don't fully understand that. I possibly even described that wrong. So please correct me in the comments if you have better insight into that. Um, so yeah, other stuff that's in here, main method, does some simple stuff. Logging, sets up logging. Again, another thing where you need to know about how to set up a logging implementation. You have to install a logging package, and then you can have that like initiated up here, which then if you down here in our HTTP server, you have to like set up the default logger, and then you'll be able to get logs actually printing out. If you don't have this like set up, this logger line down here won't do anything. So this kind of an implementation thing you need to know about. I'm gonna skip over this little bit for a minute, so we can ignore that. But the main thing down here then is setting up our actual HTTP server. So this part is actually pretty quick and makes like a lot of sense with how these things work. Usually, if you set up a basic web server, you're gonna point it to you're gonna set it up with some configuration in the middle of it, and then you're going to point it at a port that you want it to run on. In this case, I'm running on port 8080. I want to tell it to run, and then await hooks into my await async concurrency stuff. But yeah, that should seem pretty simple, and that is pretty simple. You create an instance of your HTTP server, you tell it where you want it to bind to, and you run it. It's pretty straightforward, which is nice. Um, so with that, then we'll have a look at like what the config is in here. So there's a lot of different ways that this can work. For these kind of really basic, bare bones HTTP server implementations, usually the way it would work is you'll kind of specify like an endpoint in some definition, and then alongside that endpoint, you'll usually tell it what to do, like how to handle it. So you'll have some sort of handler of sorts that tells you what to do. In this case, That's what these services basically do. So the services uh, are how you set up how you're going to handle your requests in this case. So we have a bunch of different ways to do it. I've got a service here that's going to be point to my index handler. I've got one that points to my authentication handler, one that points to my interactions handler. So broadly speaking, index is going to be the homepage of the website you're going to land on, which is my WAT UI homepage you saw with the install button. We've got an auth endpoint we're going to hit. So that is the callback that Discord does to say, hey, this guy wants to install in his server, install on the server, etc. And then the interactions endpoint, which is when I type /wat, it's where Discord is going to ping a message to me to say /wat, and then I have to reply to that. So there's a few different ways then that this server knows how to interact. I've defined 3 of those there. And so for each of those actions, basically the server will know how to handle that and what to do and how to respond. All of that is defined up here in this handlers file, which I'll open up in a minute. So the other thing it can do, it can serve static files. This isn't always necessarily something that you might have to do all the time, especially with a lot of these what you would say, very bare bones implementations of a HTTP server. This might just be a full backend thing that never has any UI, and all it needs to do is just like pass JSON around or something like that, or you send it a request and it triggers a job or something. So it might not be something you have to do, but in this case, it does provide you this ability to be able to serve static files, which I've set up. There's a /root, and then I said, oh, that points to this www root file folder, which is here. And then in here, you can see these are kind of static web assets that you might use. So you could have a CSS files in here. You could have JavaScript files in here. Turns out I don't need any of those things, but I have these few random files in here that will all get served to a browser when you hit the homepage and stuff like that. So the last thing then that we're going to do is we want to be able to probably like load some data into our like a HTTP page. So we want to load a HTTP page, but we want to inject some data into it that we don't necessarily know up front. So our HTML file. Sorry, start that again. We want to load a HTML page, but we don't necessarily know all the data that's going to be in that page up front. So we might want to have some templating system in place. So this is very common, very kind of old school programming way. If you've done like basic MVC stuff, Rails has this in its ERB files. .NET has this in its Razor files, and loads of other different types of things you do this. Specifically, I found a library that implements the handlebars JS type formatting in Rust, which I'm able to use here to do my templating, which is quite nice. So in my app, there's very little templating, but there is 2 tiny little bits of templating that I wanted to put in just for completeness. So basically, with this, what I've got is I have a templated HTML MVC type UI. I've got static files being served, and I've got regular like HTTP endpoints, so like JSON endpoints. So if you can kind of do those 3 things, you can sort of build most types of web app that you might need to build, barring some other weird things or different protocols. That stuff will get you like 90% of the way there. So this one little Discord project has exposed me to a load of different things and given me exposure to all this technology and how it works in Rust, which is pretty cool. So let's see, what should we jump into next? Oh yeah, so one other thing I suppose we're talking about is how do I run this and stuff like that, and how does it get deployed? So running it is fairly simple. This is just a main thing, so you can really click your run and debug buttons here, or you can do like cargo run, and it'll just run fine. But I decided to go a little bit fancier with that, and I Dockerized this app from the start, and I also set up a Docker Compose to work with it as well. Kind of knew I wanted to deploy this, and my deployments that I usually do to web apps in Azure are Dockerized. So by doing it here, it made it pretty straightforward to get all that working. Um, so let's have a look. Where do we start with that? So yeah, if we open up the Docker file, um, there are some Rust-based Docker images that we can use. So I have one in here, which is for Rust 1.7.6. This is a multi-stage Docker file. So I set up the build container up here. I cd into my directory, which is the root directory for this app, copy all that stuff, and then what I decide to do in the building container here is I do a run cargo install, I specify the path to be the root path. So this basically goes to it. So within this Rust container, it has all the cargo tooling in there. So it does an install. So it builds the whole thing and installs the binary into the cargo root path for this image. But for running the app, I don't actually need all of the Rust stuff in the app. I just need some, like, basically a Linux container, because this is a Linux image. I just need a Linux container in here that can just run a binary. So in that case, I have this. I pull out this Ubuntu latest container as the runtime. I was using a slimmer container, but I ran into some issues with dependencies, basically. And I still ended up with a dependency issue with Ubuntu, but it was a little bit simpler to solve. So pull down this Ubuntu container, go to the root for the working directory, and then in here I run an update and I install this package here, which is needed to basically validate an SSL certificate in Discord land when I ping a HTTP request to them. So anyway, just as something you have to install here. It doesn't work if you don't install this. And then from my building container, I just copy over a bunch of stuff. I copy over my web root assets. I copy over my template files, which I talked about. I copy over a version file, which not really relevant, doesn't matter. It's just part of my build chain process. And then finally, I copy over the Discord WAT binary that gets outputted from building and installing in the building container. So I go and find that, Discord WAT, and install that here. You'll notice that I don't have a run command or anything defined here. So this will just build the image, and then when you want to exec that image, you have to specify a build command or run command. That is because my cloud provider asks that you specify run command. And also then when I'm using Docker Compose, it can specify the run command that it should use. So locally then, when I want to run the app, I can go in my scripts. I've written a simple run script, which doesn't do anything fancy. All it does is just runs Docker Compose up with the build flag. So it'll rebuild the images every time for me. But all the Docker Compose up will do is it'll just spin up the containers that are specified in the Docker config file, in the Docker Compose YAML file, which I'll show you now, and then runs the whole app. So I have that here. Here's my YAML file. I have two services defined. I have a proxy service, which is just an Nginx server. And then I have my Discord WAT, which is my web server. So don't worry too much about why I used Nginx to do this, why I used Docker Compose to do this. A lot of these like basic web servers, when you do like Rails new or Rails run, whatever, it'll handle HTTP and HTTPS out of the box. This web server doesn't, or it demands that you basically configure it to handle HTTPS and then add certificates and stuff in there. But I don't want to do that in production, because in production land, the actual instance of the running app is just going to serve HTTP. HTTPS will be terminated at the load balancer level. So internally, the app itself only ever needs to handle HTTP. If you don't get that, it's fine. We can gloss over it. But for that reason, the main app in here doesn't know anything about HTTPS at all. It doesn't know anything about the secure socket layer. It just knows plain old HTTP. And that's all that this bind does, is just binds to localhost 8080 and will only respond to requests that are HTTP. It doesn't know what to do with HTTPS. So because of that, locally, I spin up a proxy server in Docker Compose. I set up these things in here, which are basically the certs that it's going to use. Those certs are in this Nginx folder. They're purely generated by the OpenSSL. They're self-signed certs generated in OpenSSL. They're not that important. The config file that Nginx will load is somewhat important here. So it'll listen on port 80, it'll listen on port 443 for SSL requests. Use these use these keys, these certs for the SSL, and it'll proxy to Discord WAT on port 8080, which is what we have down here. We've got Discord WAT on port 8080, and it'll proxy everything through that. So it'll terminate SSL there. So this works fine locally. Once you run this locally with the self-signed cert, first time you hit the home page, it'll ask you to accept the security risk of a self-signed cert, which is fine to do because it's only your local. It's not going to break anything. It's fine. So where does that bring us to? We've got our app running. We have it running in Docker Compose. We've got certs and stuff. Have our Docker file. Are there any gotchas with this? Oh, there was a gotcha with this. Well, not so. Actually, I kind of mentioned it earlier. When you look at Rust documentation, so I decided to use this Ubuntu runtime because it came with more pre-configured packages. I was having trouble with the OpenSSL package that they needed dependency to be installed on, and so the Rust base image, they say if you use like Alpine Slim or something like that, it doesn't have many of the packages you might expect that it needs there. So you might have to go through that manually and figure it out yourself if you need to. This had most of the stuff except for this one, which I don't even think is necessary for everything. It's only necessary in one case, which can point to in the code. Okay, so sorry, I do feel like this is very disjointed. I'm just kind of running around pointing at things, but it's all kind of coming through into my head, and I just want to get it out as in a way that kind of makes sense and that hopefully someone finds interesting. Okay, so let's have a look at some code then. So I said that we had a bunch of stuff in here defined, and we have a bunch of handlers defined to do stuff. So let's have a look at defining our handlers then that are basically set up our endpoints. So if I open up my handlers file here, you can see we've got the lion's share of all the logic is in here, and there's a heck load of stuff. So yeah, the basic way that we'll set up what the roots actually are for the handlers is we can use this annotation. So we can define the HTTP verb that this is gonna basically listen for, and the route that it's going to listen to in the route that is going to get triggered when you type it into your browser, into your URL, basically. So we've got a basic one here, which is our index route. Very common would be like just /root. And we've defined that it's going to be a HTTP get. So when you do HTTP, HTTP, Discord wat.azurewebsites.net / and like nothing else, when you just hit the homepage, it will hit this handler. And from this handler, it does a few different things in here. It checks for a query parameter, which basically says, which I use to kind of hack. It's like a redirect thing from the install flow, whether it's a successful or an unsuccessful install, and we'll do something depending on that. And it'll also load the homepage. Basically, that's all it does. So it checks that and it loads the homepage. The homepage is set up as a template. So this is where our templating engine comes in. When we go to our main, and we see in here, I have my handlebars thing all set up and registered. I have a template directory, which is this /templates, which is here. And we've set up that they've got these file extensions of .html. So index.html is how I define the root for the template. And then in my handlers, I know that I can load my template in here. Where is it? Oh yeah. So basically you define this thing in here. So you say index root, and you define this web data handler as handlebars thing, and then it knows what it needs to do to basically generate that when you call HTML and a body thing. This is what it is here. So it's you generate your HTML body that you want it to return. You call the handlebars, render the index root, which is what I've told it to, because I know this is my index here. There's my index template, and I provide all the data for it. So the data here is just formatted JSON data. So these are some of those things that will get injected into the HTML template. So we have a look at the HTML template. You can see these are the handlebar notation that does stuff. So check these, do different things depending on what you have. So one example of where it's just going to inject data is down here in the footer. We've got a handlebar that has version. Then in my handler, you'll see I load a version, which is get load from that file that I showed earlier on. Version file, which I said wasn't super important. It's not, but it's just an example of how I inject some data. And then let's have a look. If we go onto my actual website for that, you can see there's the version stamp down there for the website. It's more of a debugging thing for me than anything. Okay, so that was one thing that we looked at. And I've just looked at the clock and realized just how long I've already been talking for. And I've realized that I don't think I'm going to be able to cover everything I wanted to cover in this video. So like I've whistle stopped over a load of this stuff. There's so much more in here that I want to talk about, but I actually think I'm gonna have to leave it here because this video is getting way too long. Um, so if you enjoyed this, there's more you want to know about this, because there's so much in this that I could talk about, please let me know in the comments, and I will do my best to come back and do a follow up to this video. For now, we're gonna leave this here. I'm gonna park it, because there's just so much I could get into, and I don't want to be talking here for an hour and then having to edit an hour of stuff to something that makes sense. So I'm gonna leave this here. Sorry, this is a bit messy. I've been super busy recently. My work has been crazy and just very busy with life in general. So this is a bit ramshackle and a bit rambly. So sorry for that, but I wanted to put something out. I wanted to talk about a project and share it with you guys. So yeah, if you like it, leave a thumbs up. Leave a comment if you want to know more about this. I'd love to talk about this more and go into more detail. But I don't want to waste my time if no one's interested. So anyway, if you managed to make it this far, I appreciate you. Thanks for watching, and I will see you guys in the next one.